Welcome back. This is the second lesson recording for IM2, February 4th, 2021. So we're going to shift gear a little bit and we're going to tackle some application problems involving quadratic functions. So I have a rocket is launched from an 80-foot tower. It will rise, hit the maximum height, then land on the ground. So can you kind of picture it in your head? Okay, and see if you can come up with a diagram that represents this situation. I hope you came up with something like this. Okay, so here is my rocket. It's going to go up and then it's going to come down. If I graph what's happening to this rocket with the y-axis being the height of the rocket at any given time, the x-axis is the time, then the graph will have a parabola as a shape. Okay, it's a quadratic function. And whenever you throw something, remember, just like the basketball or anything that you throw, it's going to form a projectile that's due to the gravity that's pulling down. And that's going to be constant for always. And there are other applications of parabolas, but we're going to stick with this one for now. So then I would like you to think about this situation and tell me, what quantity does x represent? What does x represent? What do you think x will represent? I even gave you the answer. It's the time since the rocket has launched. So here, x is 0. That means it's time 0 seconds. And then all the way, the time is increasing until f. Okay, we don't know what that time is. And what quantity does y represent? It tells you, look at the y-axis, it's the height. So at any given time, it's the height of the rocket at a certain point of the rocket. So it's the height of the rocket at time x. It depends on time since rocket has launched. Alright, so same question. In a rocket launch situation, what does point D represent? What does this point D represent? Please tell me in private chat. Well, that's the rocket at the start of launch, because at that point, the x-axis, the value is x is equal to 0, or the time is equal to 0. When time is equal to 0, that means we're talking about in the beginning or at the start of the launch. How high is the rocket at the start of the launch? How high is it? What does the point E represent? Okay, what does point E represent? What do we call that point? Okay, we usually call that point vertex. But that is rockets reaching its highest point. It does not go any higher. So in that case, this is the maximum point. And that is the reason when you're talking about minimum or maximum, we always talk about its y value. Okay, maximum and minimum is not a coordinate. A lot of you are telling me maximum is a coordinate. The maximum and vertex are different things. Maximum is just the y value of the vertex. It's not a coordinate. So it's the y value, it's the height or the maximum height that rocket reaches. What does point F represent? And that's where the rocket lands. Okay, that's when the rocket lands. Okay, what about this? What parabola graph attribute is D? We said that's when it starts. So what do we call that? That's called y-intercept. What about E? What parabola graph attribute is E? That's the vertex. What about F? F is the x-intercept. It's where the graph crosses the x-axis, so it's x-intercept. Okay, now I want you to tell me in private chat, which equation below can model the rocket as a function of time? We don't know the exact numbers, but we can eliminate many of these and be left with just one equation with the information we are taught. What do you think? Okay, is it A, B, C, or D? And make sure you are clear in your mind why you're choosing that. It's not eeny, meeny, miny, mo. There is a very definite reason for it. Okay. First of all, what sort of parabola is this? Is this parabola opening up or opening down? It's opening down. So what do you expect the graph to have when it is opening down? You would expect the leading coefficient, the number in front of x squared, to be negative. So the only two negatives are a and c. So now we've eliminated b and d to be incorrect because these two are positive. If it's positive, it's going to open up and the graph is opening down. So it's either a or c. Now what else do we know? Pretty easily from the graph, we know what the y-intercept is. What is the y-intercept? It is 80 feet. Okay, so this point is 80. It's positive 80, but this one has negative 80 as the y-intercept, and it's positive 80 here, so the correct answer is C. Alright, then I want you to tell me in private chat, what is the maximum height of the rocket? When does it happen? Okay, to do that, let's assume the equation that we said was correct is actually the equation. Okay, so y is equal to negative 16x squared plus 64x plus 80. How do you find the maximum height of the rocket? Well, what sort of form is this? Is this standard form, factored form, or vertex form? It is a standard form. Okay, how do we find the vertex when we're trying to from the standard form? Standard form for the vertex, we need to do x is equal to, we use the formula negative b over 2a, where a is the number in front of x squared, that's negative 16. B is the number in front of x, that's positive 64. And c is the constant, which is 80. Okay, so b is 64, but there is a negative sign there, so it's going to be negative 64 over 2 times a is negative 16. So that's going to be negative 64 divided by 2 times negative 16 is negative 32. So 64 divided by 32 is 2. Negative divided by negative is positive. So vertex, the coordinate of the x coordinate is going to be 2. What about then y? What is the y coordinate? Then to do that, you substitute x is equal to 2 that you just figured out. So you're going to substitute to your original equation. Every time I see an x, I'm going to put 2 using the parentheses so that I do not lose anything, and nor do I lose the multiplication. Plus 64 times 2 plus 80. Okay, so this is 2 squared. Remember, order of operation, we don't do the multiplication first. We do the exponents. 2 times 2, or 2 squared is 4. 4 times 16 is 64. Negative 64 in this case, plus 64 times 2. That is going to be 128 plus 80. Okay, so I know that negative 64 plus 128 is positive 64 plus 80. That's going to be positive 64 plus 80 is going to be 144. Okay, and it is the height, the y-axis is written in feet. The unit for that is feet. So what is the maximum height of the rocket? When does it happen? What is the maximum height? So maximum height is 144 feet. Again, when you're talking about maximum, we're talking about the y value only. Okay, when does it happen? Well, we're talking about what is the x coordinate. Okay, and we figured this to be 2 seconds. So it happens when time is equal to 2 seconds. Okay, let's try the next problem. Okay, so next problem is asking you, when does the rocket reach the ground? When does the rocket reach the ground? What point are we asking for? We're looking for this point F. Okay, when it hits the ground is down here, because that's when the height is 0. When the height is 0, that's when it lands on the ground. And how do we figure this out? Well, if you said, okay, so this is 2, that means I know that this distance is 2, so this distance has to be 2. That's not correct. Okay, so it's not going to be 4 seconds, because where it is reaching, where it is symmetrical is this point, and this is sort of, it does not exist in real life, but the parabola, if I was to extend it, it will be down here. That's the other x-intercept. Okay, so we're looking for the x-intercept here, aren't we? So how do we figure out the x-intercept? To figure out the x-intercept from the standard form, we actually need to convert it to factored form. Okay, so to factor form, that means we need to factor this expression. So first thing I always look for is GCF. Otherwise, I'm going to be multiplying 16 times 80. That's going to be a huge number. Okay, so first I think, okay, what is a number that is divisible by all? 16, 64, 80. I'm thinking, okay, maybe 8. Okay, and I am going to take out a negative number. I would much rather deal with x squared being positive, so I'm going to try to take out negative 8. So that leaves me with negative 8 times what is negative 16? That's just going to be 2x squared. Negative 8 times what is 64x? Negative 8 times negative 8 is positive 64, so that becomes negative 8x. Negative 8 times what is negative 80, so it's going to be negative 10. Okay, so here is what you should notice. Okay, when I look at this number, I still see they are all even. That means I can take out another 2. When you see even numbers in front, that means I can take out another 2. It so happens that 16 is the greatest common factor, but I did not see that. But that's okay, because as you reduce it into smaller numbers, you are going to be seeing that. Okay, so then I'm thinking, okay, no, it's not just negative 8. I need to take another 2 out. That leaves me with x squared minus 4x minus 5. Okay, so that becomes negative 16. And now we need to factor this. This is my easy type. Okay, so then I am looking for what are the factors of negative 5. Okay, negative 5 means one's going to be positive, one's going to be negative. So the only factors are 1 and 5. I know one's going to be positive, one's going to be negative, which I want the sum to be negative. That means I need the bigger number between 5 and 1 to be negative, because negative 5 plus positive 1 is going to be negative 4. So now that I have factored, I know to find my x-intercept, I can split this into 2 sections, 2 equations. X plus 1 is equal to 0, or x minus 5 is equal to 0. And so in this case, subtract 1 from both sides. Oops. And that leaves me with x is equal to negative 1. Add 5 to both sides. And that leaves me with x is equal to positive 5. So it happens this is positive 5. And this point that we said, if we extended it, it's going to be negative 1 there. Okay, so we figured out that it's going to be positive 5 is the real x-intercept. So when does it reach the rocket? When time is equal to 5 seconds. Okay, for the rest of the period, we worked on the review packet. Okay, so there's a Unit 7 review packet that reviews the graphing portion in vertex form, standard form, and factored form. And then unit number 6, factoring review, I am actually going to give you the independent factoring practice worksheet that I gave to my my workshop students. You're not going to get extra credit, but you can certainly do for extra practice. And I am going to release the worked out solution key on Sunday morning. okay, so that you can check your answers. That's it.